All right, okay, so hello, dears. Emphasize the T, char. Anyway, hello, dears, again. Good day. Welcome to another pre-recorded lecture in our Immunology and Serology Laboratory. And for this lecture, what we're going to discuss is another basic concept that you must learn, that you must, be aware of, okay, for you to really appreciate our course even better, no? And this is your precipitation reactions, no? So this is one of the reactions that we are going to discuss, all right? One of the basics pa lang. So precipitation ang first, and then our next lecture will be on agglutination reactions. And then finally, on the later part, we'll have labeled immunoassays, all right? So labeled. All right, sana all my label. All right, so may pang immunoassays na i-label. All right, so but this part, this is in the later part of the semester na. All right, so we'll start first with precipitation and agglutination. So precipitation and agglutination, in ana siya guys, that's agglutination ha. These are actually called unlabeled immunoassays. All right, so when you say unlabeled, they do not, parang your antigens do not have labels, all right, in the form of enzymes, in the form of mga fluorescents, whatever. So you'll understand more on labeled immunoassays again when we discuss that soon. And muna akong ikahadlukan na topic po kaya medyo kailangan ng brain cells, all right? Okay, but may mga pinagdadaanan tayo, so wala na akong brain cells. Anyway, but again, so we'll start first with the first one, precipitation, and then followed by agglutination reactions. Again, one of the basic concepts, some of the basic concepts rather, that you must learn and be aware of in our course in Immunosero. All right? Okay, so again, this precipitation, this PowerPoint presentation is again made by Sir Jemu, the best. And as you can see, diba, precipitation, so muna ang background kay rain. So parang wordplay, no? And when I was still a student, this is one of my favorite na PowerPoint ni Sir Jemu yun. Kaya it's nice kaya yung color. Ganan kay ko, kaya it's very calming. Ganan kay ko sa color and all that. So muna siya kong one of the best niya and one of my favorite na presentations ni Sir Jemu. And I hope you appreciate it also, the way I appreciated it. Okay. All right. So we'll start first with your immunoassays. So, why are we talking about precipitation and agglutination? Because these reactions are what we exploit, mujin akong term na nasa akong mind, or what we use as a basis for our immunoassays. And these immunoassays are what we perform now in the lab, all right? So, we follow the reaction, or we follow we base these immunoassays on these two reactions, okay? Generally, you have precipitation and agglutination. And for the first part, we'll talk about precipitation. So, again, immunoassays, it employs the combination of both the antigen and antibody. So, again, diba, we have already discussed in our lecture on antigens, antibodies, their reaction, diba? Alright, diba, the fragment FAB sa epitope sa antigen, no? So we'll now go into their different reactions, alright? And these reactions, as mentioned, are the basis now of your different laboratory tests, serological tests to detect diseases, no? May it be of different origin, bacterial ba, viral, no? Fungal, whatever, alright? And we'll start first with precipitation reactions, alright? So again, just a recap, antigen plus your antibody, diba, it has a specific FAB, all right? And they will combine to form an antigen-antibody complex, all right? And this general reaction is what we follow in our immunoassays, all right? Okay, precipitation ba na, agglutination, or your labeled immunoassay, it all follows this general concept of the antigen and antibody reaction, and once they react, they form an antigen-antibody complex, okay? All right, ayan. So again, immunoassays throughout the years have been developed to detect either antigen or antibody, depending on the need, depending on the test, depending on what you want to discover. All right? And many assays, again, are based, as mentioned, on the principles of precipitation and agglutination. And agglutination is the visible expression yun. So makita siya. Makita yun ang visible, makita ang reaction between the antibody and antigen. All right? Kung agglutination. All right. Now, some immunoassays, again, are, as mentioned, based on precipitation and agglutination. Some of the tests are already obsolete. They are not usually performed na on routine clinical lab nowadays, but it still pays, no, for us to know no? Theoretical. For our knowledge, lumalabas pa rin sa boards kahit papaano. Okay? All right. Now, for the next part, we're going to differentiate now between precipitation and agglutination. What is the difference between the two? All right? Okay. So, for the first part, you have precipitation. Ang key point lang yun sa precipitation is you both have two soluble antigens and antibodies. All right? And it now forms your insoluble complexes, all right? Because of their reaction, it now precipitates out of the solution. But the main point is that both of them are soluble, meaning they're all in solution, okay? All right, whereas for agglutination, your antigens, or pwede antibody, na-adjuusan nila na insoluble, all right? Or particulates. So you have particulate antigens plus soluble antibodies will now result to a larger clumps or complexes, which can be seen in the naked eye. So, since your antigens are solid, okay, your antigens are solid. Usually, the antigens ang solid, kaya ang antibodies usually siya man jud ang naa sa solution, kaya nasa yung serum and all that. So, once they react, no, they now form large complexes or mga kumpol-kumpol, which can be seen in the naked eye. All right? Okay, example, Ana, is of course your blood typing, di ba? Katoy yung mga kumpol-kumpol. That's an example of agglutination. Because again, the antigens are found on your RBCs, no? So solid, okay? And then, butangan natong anti-sera, katong colored na, ano nato, which contains antibodies. So pag-react nila, they form now aggregates, alright? Or complexes, or clumps na makita nato. Whereas for precipitation, the reaction usually insoluble man, so dili siya makita with the naked eye. So what we do is ato siyang ibutang, og example, ibutang ang reaction sa agarose or agar gel, whatever, para makita ang example precipitin line na mahitabo or ang precipitation na mahitabo. Again, because again, they are soluble, all right? So for the reaction to be seen by the naked eye, ato siya ibutang sa example agarose, agar gel, example like that, all right? We'll discuss that later. Okay, all right. But for agglutination, it's not necessary that kailangan ay agarose or agar gel. Pwede para sa blood typing. Your blood, excuse me, blood drop, no? And a drop pod of the anti-serum, mo react na siya dayon. All right? Because again, the antigen is solid, all right? And mo react siya dayon, so makitaan. All right? Okay. And for agglutination, usually, in our lecture on agglutination, there are different types of agglutination. The antigens are usually coupled, di ba, with a carrier. Remember? Last discussion natin sa antigens, antibodies. So a carrier, for example, latex carrier, pwede po charcoal, pwedeng bacteria mismo, no? So we'll know that in the agglutination lecture, all right? But we'll focus more on precipitation. So soluble antigens and soluble antibodies. So both of them are in solution, insoluble complexes, all right? As akong third year, how I differentiated it na lang is sa size or like in terms of their composition. Sa antigens. Usually, antigens ang gi-focus. For agglutination, it's usually solid yun. So like, in a way, dagko, alright? But for precipitation, soluble, so naa siya sa solution, so medyo gagmay. But again, I think that's not correct. Just to differentiate the two, alright? But I hope you get the difference, ha? Alright, okay. Ayan. Okay, now we go now to precipitation agad. We'll start first with history. So who discovered it? So precipitation is attributed to this person, Rudolf Koss, all right, Koss. As mentioned ako, di ba, at the start of IS, usually sa board exams yun, if na yung mga history na yung mga tao mo gawas, it's usually sa ISBB yun na mo gawas, all right? Kaya daghan kayong tao behind your immunoassays, behind the different reactions, different tests, all right? And aside from ISBB sa micropara, pero seldom ra gyud sa micropara. Sa ISBB yun ang usually ng mga history, all right? So it pays for you to know kung kinsa ni mga tao behind this. And we thank them, no, for having the brain cells to really go out of their way and to discover new stuff, no? Actually, ma-amaze ko ani ng mga tao, guys, no? Like the brain cells that they have, grabe good. Like, you know, what triggered them or what inspired them or like what is behind their minds or like, you know, like what pushed them to really study this. And it's really, you know, amazing if you come to think of it, no? So it, you know, they deserve a round of applause, good. And although nagsuffer ta kay kita nag-study ta ani karon. But let's also thank them because of them a lot of diseases have been cured, a lot of diseases can now be diagnosed, no? So thank you guys. Thank you Rudolf Koss. Okay. All right, so this is Rudolf Koss. Yes naman. Parang murag imong mga uncle, no? Mga tito na kanang every Sunday kayo mga sa inyo ha, niya, maghubog-hubog with your father, niya, magkantag tats by tats. Joke. Sorry. Okay. Sorry, Rudolf Koss. Thank you pa rin. Thank you pa rin. No disrespect, guys. No disrespect. Alright. Okay, so how did he discover precipitation? He's a bacteriologist, immunologist, and what happens is filtrates of bacteria, enteric bacteria, mo precipitate siya when mixed with antibody. Alright, so both of them are in solution pa rin. So, iyahang i-combine ang bacteria, no, filtrate sa yung culture, and then a specific antibody, and then pag-combine niya, nakita niya na na-precipitate na may tabo. Alright? So, thank you, Rudolf Koss. So, precipitation. That's the early beginnings, mga humble beginnings ng precipitation. Alright. Next, we go now to, again, we now delve deeper into antigen-antibody binding. Because again, this is the basic, no, or the parang in a way the central dogma, char lang. The basis of your different reactions. It's between the antigen and antibody binding. All right. So the primary union of binding sites of antibody with the epitopes on antigen depends on two characteristics of your antibody. So the strength, no, of bonding between the antibody and antigen depends on two characteristics of the antibody, which is known as your affinity and avidity. All right? Ayan. So affinity, when you say affinity, is the single force lang, initial force of attraction that exists between a single Fab site and a single epitope of an antigen. So usara ka force, all right? Initial attraction. So, sige, let me erase. All right. So, example, you have an antigen. Okay, this is your antibody. All right, and this is your antigen. So, the initial attraction aning duha, all right, that's called an affinity. All right? But, when you say avidity is the sum of all, tanan na gyud, tanan-tanan. All right? So, dili ra ang usa. All right. All right. So, example, avidity, it's more on tanan-tanang forces na. It does not only focus on one Fab site, all right, and it's not focusing on only one force that keeps the binding intact. All right? So, avidity, a point lang yun, key term is the sum of all the attractive forces. Kay, sa affinity mismo, kaning usa pa lang daan, no, initial force of attraction, that's only one force behind that. Example, hydrogen bond ba, or van der Waals, no? But for avidity, it's the sum of all. All right? So, apil lang hydrogen bonding, apil na ang van der Waals, tanan-tanan. All right? Avidity. Okay, ayan. So, affinity, so, di ba, affinity, we'll start first with affinity. So, if mo bind na ang antigen o antibody with the epitope and the Fab, no, several non-covalent bonds ang naa. So, please, this is just a review of your general chemistry then. So, first is ionic bonds, oppositely charged particles, hydrogen bonds between polar molecules, no? So, usually with the hydrogen, basta na ay molecule na hydrogen bonds. Next, you have hydrophobic. By the name itself, these are bonds that are, do not like water. All right? Yeah, non-polar molecules and exclude molecules of water particles. And lastly, the van der Waals. All right. Mga dipose, no? Di na ako mo delve deeper, ani. Kaya medyo nakalimot na pod. But this is a review of your Gen Chem, diba? And usually, the ionic bonds are strongest, ani, if I'm not mistaken, ha? All right. And the van der Waals ang weakest. Okay? All right. Ayan. So, these are some of the forces that in a way, helps in the binding of antigen and antibody. All right? In affinity, in one Fab, okay, and the epitope of the antigen. All right. So the strength of attraction, again, depends on the specificity of a particular antigen. So if, example, your antibody is really made for that antigen, all right? So it's really stronger. Okay, that antibody is really for that. No, it's really specific. But we have what we call your cross-reactivity. Cross-reactivity, some antibodies are capable of reacting with other antigens that of similar lang. Dili jud ang exact. So example, you have two antigens. Let's say, you have two antigens, muna yung epitope, and you have another antigen na inani ang epitope. So as you can see, example mo, bind ang duha ka antibodies diri. As you can see, this is like example, the main antibody binds on this. Alright? Ayan, sorry akong drawing. Your antibody can also bind on another. Alright? Because na ay same. Alright? But it's not exactly similar. That's the point of cross-reactivity. Alright? Okay. So, not totally strong ang ihang binding. Alright? Compared sa original gyud. Alright? But for cross-reactivity, okay, mubind or gapon siya, but medyo weak na siya. Because again, the antigen is quite similar, all right, but it's not exactly the same, all right? So here's an example of a picture. So this is your antigenic determinant, and this is the Fab. Ayan. So this is the initial or the original antigen, all right? So strong yun yung affinity or ang pagbind because again, the antibody is really made for this na inani ang itsura na antigen, all right? But this antibody can also react with this other antigen because as you can see, na-adya po niya siya na part, okay? But kani ang wala, all right? So in a way, same siya appearance ng antigen. All right, but the antibody can still bind, but the affinity or the binding is not as strong. All right, so I hope na-gets lang na. All right, that's for affinity. Okay. Ayan. Now we go now to avidity. When you say avidity, it's the strength of a multivalent antibody that binds a multivalent antigen, and it's the overall measure na of stability of antigen-antibody complex. So once binding has occurred, it's the force that keeps the molecules together. So example, ayan. So multivalent. So as you can see, daghan na, no? Usually it's the overall na good force that keeps the antigen-antibody complex intact or the binding intact. So as you can see, di ba, if another way to look at it is if affinity, it's usually one antigen, one antibody lang. Whereas for avidity, tanan na gyud siya, no? Several multivalent antigen, meaning daghang binding site, and multivalent antibody. All right? Gets lang, as you can see. That's avidity. All right? And again, it's the force that keeps the molecules together. All right? So, sa mga relationships dyan, make sure na strong inyong avidity. All right? Dapat dili lang affinity ang inyong look, dapat avidity good. Ang end goal na to guys is avidity. Okay? End goal, avidity. All right? Ayan. Okay. Ayan. So, multivalent antigens and the multivalent antibodies or bivalent. Alright. Ayan. Okay. Ayan. Sige. So, balik tayo, no? Ability, again, multivalent antigens, multivalent antibodies. Alright. So, example, your IgM is multivalent. Alright. Daghan siyang binding sites. Alright. Ayan. So, your IgM, yun, strong gina siya avidity. Because, again, multivalent man siya, daghan siyang pwedeng i-bind. Alright? So, muna siya point, ana. Avidity is the overall, alright? Overall, sum of all the forces that keeps the antigen-antibody complex reaction intact. Okay? Alright. So, muna siya. End goal na to sa atong relationships, dapat strong atong avidity. Charot. Okay? Alright. Ayan. So, again, this is from Stevens pa rin, guys, if you want to read on. This is, I think, chapter 9. Basta principles of immunological and serological reactions, I think. Yes, if I'm not mistaken. All right, now we go now to what we call the law of mass action. Again, if kabante mo, there's a lot of chemistry behind this, no, mga general chem. Also, this is a law of mass action. If I can remember it correctly, it's also about talking about equilibrium, all right? Here in sa chemistry and also here in antigen-antibody reactions. No, there's no, the antigen-antibody reactions are of no exception. All right? It follows what we call the law of mass action. So, antigen-antibody site is reversible. So, when you say reversible, magbalik-balik siya. So, we'll look at that in the reaction later, reaction equation. And it's governed by this law. Again, ang point lang is dapat na equilibrium and there's a constant K that represents a difference in the rate of the forward and the rate of the reverse. All right? So, ayan. So, this is an example of an equilibrium, di ba, reaction. So, when you say reversible, so, kani siya mo react to form this, and this can also dissociate, or pwede sila magbulag, alright, to create this again. So, muna siya point sa reversible reaction. Recall in your chemistry, di ba, inana siya. Alright, okay. And you have the K and K. This is the rate, or equilibrium constant. So, this is the rate of the forward, ang K1, and K2 is the rate of the reverse. Alright? Okay. Ayan, so ako na siyang explain. Alright. So, K, therefore, usually we determine the K by dividing, diba? So, K1 over K2. So, the concentration of the antigen-antibody complex over the product of the concentration of the antigen and the concentration of the antibody. Basta gani, diba, in your chemistry, I hope ma-remember lang, basta in ana gani, it talks about concentration of the, kung unsay nasa sulod. So, concentration of antigen. Alright? Okay. Ayan. Okay. Alright. So, as avidity increases, ayan, sige. We have a parang rule of thumb here. As avidity increases, the tendency of the antigen antibody decreases. Alright, okay, sige. Ayan. Sige, let me explain. Diba? Muna siya ang imuhang formula. Alright. Now, what it says, no? As the avidity increases, so mas magka-stronger imuhang attractions mo, mas stable, alright? The value of K2 decreases. So, asa man ang K2? Diba? It's the reaction padulong balik dito. Alright? So, what it does is, of course, if you come to think of it, strong na ang antigen-antibody reaction. Ang complex mismo strong na, kay taas nag-avidity. So, therefore, less na lang ang chances for this to dissociate. Therefore, less na lang ang chances na ma-form ni siya na product. I hope na gets lang. Alright? So, therefore, the value of K2 decreases. So, this decreases. Okay? So, unsa may reaction na sa K. Diba? It increases. Because, again, this is inversely proportional. Diba? I hope na gets lang. So, if mugamay ni siya, mudako ni siya. Kagets lang? So, let's say, your K, normal ha, normal. Katong original pa lang. Ang K1 daw is 0.1 and then ang K2 is 0.1. So example, 1. Okay? That's 1. Alright. Now, ay, tama ba? 1 ba? Joke. Ayaw na lang na kayo mas maglibog ko. Alright, 1 over, let's say, 1 over 1. Okay, so example, adili na pwede. So example, 1 over 2. Okay? Alright, so this is example 2.5. Okay. Now, let's say the 2 decreases now because, again, the avidity increases, no? So, the less na ang chances na ma-form ni siya na product. So, therefore, the constant, K2, ang reverse, pabalik, mo decrease po. So, example, mahimo na siyang 1. Alright? So, that's now equal to 1, ang imong overall K. Therefore, ni-increase na imuhang constant. Okay? Nag-gets lang, guys. I hope na-gets ra. I hope na-gets ra. Nadlok ko. Alright, but I hope na gets lang, no? Because again, as avidity increases, meaning strong na gyud imuhang complex, strong na gyud. Therefore, less na ang chances or wala na gyud siya time para mubulag or mo dissociate. Therefore, kani siya na reaction, dili na kayo ma-form ni. Alright? So therefore, ang imong K2 or ang constant, the rate para ma-produce ni siya na product is mugamay po. Therefore, again, following this, mugamay man ang denominator, alright? So, ang K po, therefore, mo increase. Ka-inversely proportional man. I hope na gets lang, ha? Alright, okay. Now, for the next video, we'll continue with precipitation and we're going to discuss the precipitation curve. Alright, so many precipitation curve. Na-flatten na ba ang curve? Charot. Okay, alright. So, thank you, dears, and I'll see you in our next lecture.